Hello, everyone, and welcome to the session going from DevOps to DataOps. My name is Ali Khalid, and I'm joining here today from the lovely city of Dubai. And a very good morning and welcome to everyone who is joining from different parts of the world. Um, DevOps, DataOps, there has been a lot of conversation over the recent years on the subject, and it is picking a lot of momentum, and I feel is going to be certainly is a game changer for organizations that do it well. Let me share my screen and let's get the conversation started. So let me give a quick intro to my background. I have been working in the analytics space for a while with large enterprises and medium to small size organizations as well. And over the past few years, primarily my job has been to help teams transform their practices in terms of implementing data ops, and which we will talk about some of the principles today, and also help them organize in a more product oriented structure, which is another term like somewhere towards the concept of data mesh architecture. So let's look at the agenda for the talk today. First, we'll talk about why DataOps is different compared to DevOps. And then we'll explore some DevOps principles which analytics teams can focus more on. And finally, data observability and some lessons learned there, which are more relevant to the DataOps space and teams can consider more closely. So DevOps versus DataOps, and what's the difference? So it helps to understand what kind of applications DevOps principles are serving. Of course, they're primarily going to be web applications, web services, etc. And these applications typically on the front end, web services and database layer, you will have code. Of course, on the web service and UI, it's going to be quite intensive. The amount of data that is traveling through all these stages or pass through is not going to be as much, right? As an OLTP system, it's going to be transactional in nature. So these are usually code heavy with relatively lesser data. Therefore, the focus of all DevOps principles and practices has been around how to improve building modularized code, how to deploy code, how to test code. Now, in the analytics world, the problem we have is we have a lot of data as well, right? And our pipelines are a bit different, and the amount of code that we have might not be as intensive as it is for a web service or a microservice, let's say, but nonetheless we do have code which is spread perhaps across multiple business domains and also across different platforms in some cases, and that adds a lot more complexity to the solution, therefore making that single touch deployment, CI/CD, and the DevOps culture a bit more challenging. Therefore, we need to consider a few more variables to reach to the result what we get from DevOps. So the DevOps component would remain the same. So DataOps would equal to DevOps plus data observability. Now we have to add a few things for data to manage the large volumes of data. So of course there are going to be data observability and data management. Now when we add both of these, that would give us enough observability and enough rigor in getting the required analytics solution very quickly into production, which is more meaningful, is customer centric, and again all those good principles and practices. So in today's discussion, we'll talk about few DevOps principles and a little bit about observability. Now again, all of these are very big topics in themselves, so we'll just pick and choose a few things to talk about. The principles of DevOps originally stem from all the agile practices and the agile manifesto, of course, and it's just an extension of how to achieve that agility in a tech space, which for building enablers like CI/CD and etc. To enable quicker releases. But also, DevOps, more importantly, is a culture, right? It's not just about tools, it's about culture, and that's why in the principles that it reflects there: customer centric action, create with the end in mind, end to end responsibility, cross functional autonomous teams, a big one. For analytics teams, even more important because we usually do deal with a lot of different platforms, and it helps to have all that capability within those teams. So you code it, you own it, and teams take the ownership, and they have the required skill set within the team. Then you have automate everything you can, and finally continuous improvement. Today we are going to talk more about in the areas of automate everything you can, and that will help with continuous improvement. The first thing is modularized architecture. Although data pipelines are built of a lot of smaller components, smaller jobs running sequentially, however, but still, in my experience, a lot of teams, when releasing analytic solutions, they're not able to release it in increments, and they happen to be more big bang, which is, if I want to release, let's say, a new table in my data mart and some additional columns in my semantic view, they would say, perhaps we need to do all the ingestion and the curation and the modeling and then the semantic, and we release this whole thing in one shot. However, you could sometimes very well just release the curation part, and someone might say, how does that help, because the end consumer doesn't necessarily get that. But there's a lot of value in pushing things into production early on, because you start to see issues, you're able to pivot, you're able to see anomalies which perhaps we are not able to see in lower environments. So what I'm trying to get to is, systems should be loosely coupled, and to do that you need to have separation of concerns. So each component is dealing with a very specific area and doing that job only, and then the remaining components have their own specific areas or modules, or components are focusing on specific functionality. That helps with components of pipeline being deployed, tested, developed, tested, and deployed independent of one another. The concept of data products also will add value or help in this regard. If we look at different components of the pipeline as separate products, then that would make things a bit easier for the designing, solutioning, and the delivering of these products as well. The next one is branching and merging. Now, a lot of teams sometimes in the analytics space, because the code is not very code intensive, right? The coding practices sometimes are not very mature. For example, branching and merging strategy, they might just put code in Git and perhaps have some long-lived feature branches, and keep on adding feature branches, and there isn't necessarily a good way of moving feature branches, merging it with master. So there needs to be a strategy which the team follows for branching and merging. Importantly, all configs should be part of Git. In the analytics space, we do have a lot of configurations, parameters, etc., that go along with our jobs and connections, and all of that should be part of code, which then makes the deployment part a lot easier, and it's then version controlled. Taking that one step further is infrastructure as code. So along with not just the job specific configurations, also the cluster settings of the platform that we want to spin up also needs to be part of code. And again, that helps with the ability to track changes in the infrastructure, makes deployment a lot easier and quicker, and it takes teams one step closer to managing their platform and adding a lot of oversight into the platform. Automated tests is unfortunately not as common as it should be, in my experience in the analytics space. Um, in a typical microservice architecture, is this of course commonplace, right? You will have stages of tests happening at different layers of the CI pipeline. Um, in a data pipeline or analytics solution, the ideal world should have unit tests, which would be looking at different running tests on individual functions or methods within your job. And we may have job level tests, which is looking at one job holistically and putting in a bunch of mocked data, running the job and validating the output, or any permutation that goes well with that job type. And then you will have integration, which is across the pipeline from ingestion till the warehousing. Now these three stages, all of them have different purpose, and they would be looking at specific aspects of the pipeline. And also they could be done with different data permutations as well, which is why there is importance in having these different levels. Teams can of course choose what is more suitable for their solution and the maturity of the team that they have today. Now all of those points that we discussed earlier are big drivers in having a robust CI/CD pipeline. So you have automated validations running in as soon as a change is committed into the code repository, and a, let's say, a pull request is raised, and as soon as it gets approved, the CI pipeline triggers and the whole process starts, right? And that is where we want to be. So first go ahead and deploy, let's say for example in your dev environment or stage environment, deploys the jobs, runs different tests at different components, and then spits out a result of what's happening, and depending on the result it would deploy to the next environment. Now all components of the data pipeline need to be testable and deployable through CI. And if we have places where there is manual intervention required, then that creates a lot of issues, and the teams then don't get the benefit that they would otherwise with a CI pipeline as soon as you introduce a manual process in there. So ideally all of this is supposed to be single touch deployment. As soon as a trigger appears, let's say a pull request gets approved or you want to move to production, and you just set a flag, you should have the capability of moving that, fetching code from Git and deploying it from scratch in production or in any environment. And that's where the real value is, and it's absolutely possible to get there. It's just a matter of the individual smaller configurations on the job level and cluster level which need to be managed. And as soon as you do that, this is very much possible. Now all of that helps with having smaller and quicker releases, which is what we're trying to get to. So the trick here is, instead of having very big changes and big bang approach where as we spoke about earlier, you have a lot of different jobs being changed which are collectively delivering a feature, we should have the capability of releasing smaller components of that in chunks. So we go from monthly releases to daily releases, and that's the whole idea. So you reduce the footprint of what is being released, and when we have the capability of validating that release, then that enables confidence in releasing, and negligible effort to deploy, which is absolutely essential, because and I think that is one of the bigger reasons why teams sometimes are not able to go with smaller releases, because there's just a lot of overhead in having to do that. And finally, there is a lot of value by putting things in production sooner. In the web services world, of course it does, and that's why the whole DevOps thing is there, and it's now commonplace. In the analytics space, I feel it's even more important, because a lot of the result or the value that is going to come to the consumers or business users is from how our pipeline is interacting with the data and what kind of data they are getting at the end, what kind of data we are serving. And we cannot be really sure of what is going to really happen unless we put this in production. So it's extremely important that we put smaller components as soon as possible in production. The consumers or end users or in the engineering teams have an opportunity to observe how that interacts with live production data and then pivot accordingly. And if we have the capability of making editing, doing a change quickly and deploying it, then it becomes a lot easier and an easier conversation with business users and engineers to do smaller deployments and pivot very quickly and improving the analytics solution. Now we move on to talking about some data observability principles which teams can put more focus on. And in data observability, a big component of that or related to it is data quality. And I think while there's a lot of conversation that happens around data quality, um, over the years, in my experience, I've tried to gather all the different areas which hinder teams from scaling data quality. Creating or setting up data quality for the first time is relatively easier, but scaling it along with your pipeline and as the usage increases, that is the tricky part, and teams often run into bigger problems when they reach there. And in the mind map that you are seeing on the slide here, I've added a lot of different areas which teams can put more focus on for scaling data quality and the common pitfalls. There's an article linked to it which I will send in the chat as well, and you can read into more details over there for different components. But today I'm going to talk about just a few areas from this mind map. We spoke about some things around design fundamentals. For example, we talked about modularity, which comes under maintainability there, and reusability. Governance again speaks to the data management aspect of DataOps, which we spoke about earlier. There's a whole set of tooling which I've kept as a separate section over there. Ways of working, very important. We spoke about some things in the DevOps conversation earlier. And then we have engineering practices, which has to do with CI pipelines and a few things like data contract, which we will touch on in the coming slides. Now, the one area which I do see time and again teams struggling with is allocating capacity to investing in data quality. And the assumption at times is if we get a tool which is going to just automate most of our data quality for us, there might not be a lot of human intervention that we have to do, and teams or engineers on teams might not have to spend a lot of time, which isn't necessarily true, right? So and we will talk about this in the next slide. So the invest in quality is something which I feel analytics teams can do a better job at, and we need to dedicate some capacity from the Scrum team to work towards data quality and also to prioritize what to validate, because the data pipeline is a massive usually collection of different jobs. Now which ones to focus on can be a game changer, so you need to prioritize which ones we need to work on first. So and I feel the invest in quality compared with how much dev versus quality spend that the team is having is usually gives a good idea. I don't It's not necessarily ideal to have a benchmark figure of how much capacity should go to how much percentage to dev and how much to quality, but it's just a measure to see that are we perhaps doing enough. Perhaps if you're saying our quality versus dev spend is, quality spend is, let's say, 5%, then perhaps we might want to look into that. Getting information from people. Now, why data quality problems exist? A lot of it sometimes comes from source systems, and this has to do a lot with the data governance, data stewardship, data management piece as well. But the trick, and the people I've seen successful in doing good at data quality are those who are able to get information out from different areas of the organization, and that requires someone with good networking skills. Typically, engineers don't, it's not a they don't enjoy doing a lot of networking. I think therein lies the problem, which is why then we have roles like data analysts and all. And that's okay. If you have an analyst on the team, extremely great, and that's how it's supposed to be. But if you don't have analysts and you just have engineers, then one of the engineers has to take that responsibility of getting information, and that requires good networking and know where to get information from, because in a lot of cases you have different sources coming from different places. Who to talk to does help a lot, and the ability to dig up and synthesize information. Sometimes there might not be a lot of documentation on how the source system is working and what the data that we are getting, what does it mean in the context of the business use case. So digging that information and putting it together is an extremely important skill, and all of this is the best person suited for this is, of course, the data analyst. But in case you don't have one on your team, then perhaps one member of the team might want to take that up. Data contracts. Happy to see this is becoming a very common conversation in the community now. And for the longest of time, I've been pushing teams to have a definition of what I call good data from source. A lot of times we get an issue, or in our mind we feel as an analytics team this is perhaps not the way the data is supposed to be represented, but the source team does not look at it that way, and for them perhaps it makes sense. And therefore the importance of data contract is a lot more, and we should have a definition of what good data means that we're ingesting. And there needs to be a process of validating and rectifying that deviation. The proposal in some cases I've seen is that source systems should validate the data before sharing. Now that is that is ideal and how it's supposed to be, but the services world isn't necessarily in a habit, so to speak, of running data quality or running actual validations on the data that is being generated in real time for all their transactions. It's just not something that they do regularly. However, for analytics, that is something which is hopefully commonplace in most teams. So the ideal way is as source system to have those validations, but if they don't, then the ingesting team or the analytics team, as soon as it lands in your raw layer on your data lake, we definitely can do that validations over there. And once we do identify an anomaly, there needs to be a process of rectifying that deviation. How do we go about doing that? Also, the way we have a contract from our source, I feel we need to have something of that sort of a contract with our consumers also, which comes in the form of business metrics and what we call data quality requirements from business users. In whatever shape or form you can have that, but it's important to have some idea of the definition of good data from different business users. Severity of issues, and I use this term a lot. I haven't seen anyone using this before. Is neglecting alert syndrome. What happens in a lot of times when teams start doing data quality or alerting, pipeline monitoring, etc. They raise alerts and a lot of different any anomaly they see, and in time those alerts become, they get a lot of alerts, and they become immune to actually doing something about those alerts, because they just get so many of them, and a lot of them are um, false alarms, and we just learn to neglect them. So it is important, and how to deal with it is assign severity to the different notifications that go out, different alerts. So some of them are going to be just something that we just want to monitor, right? So we can call those monitoring level. Some of them would be high in severity. For example, if there is a some mandatory fields are missing, perhaps we might want to go in and double check. Some might be critical, wherein the loss of data is impacting the completion of the pipeline, and perhaps it might end up in not generating a semantic view that might be critical. Finally, have it helps to also have an escalation matrix. So for example, a alert which is traditionally monitoring or low, but if it keeps reoccurring, then you might want to escalate it into a higher severity or a critical one. So that if it turns into a problem, it automatically escalates and someone can look into it. Finally, share results with business. A lot of times I've seen that data quality validations just live within the engineering team and they're the only ones consuming it. Um, and of course, the motivation there is, if we share the anomalies with our business users, they might not be um, so forthcoming with all the issues that perhaps we see in our pipeline. And they might not, in an ordinary situation, it might just pass by and they might not notice, but we notifying them is just going to highlight it. Um, I think the reality is to the contrary. It does give a lot of confidence when you share the good and the bad with your business users. While there might be some failures, yes, and that would keep the teams on their feet, but it will also show or demonstrate that there is a lot of validation that is happening and it's passing, which gives a lot of confidence to business users. And I believe and I've seen that when that happens, even if they do find anomalies, they're more um, forthcoming, and they're more generous with allowing teams to give time and work on it, because they do know that there's a lot of good work happening, and you know things do slip by. But if they don't have any visibility into the health of the pipeline and they do find issues, then of course that becomes they become more cautious. And finally, it helps a lot, of course, to involve them in the data quality process in defining the data quality validations, especially on the semantic layer. Because then that way, whatever validations they want to do, we can do that for them and share the results with them along with our on a daily basis, and that would again give a big boost to the confidence. These were very big topics, data ops, and the different components of DevOps, data quality, data observability, and data management. We've tried to cover some very important principles that I have seen teams struggling with, more common across enterprises, large enterprises, and smaller teams. And these are just a few nuggets and from my experience. And thank you all for listening and taking the time. Let's continue the conversation. I'm pretty active on LinkedIn, so do hit me up. And if you have any questions, I'd be happy to answer them along with the conversation that is going on in the chat.